Imagine checking into a hotel where your window view is Earth, glowing blue beneath your feet, and the only thing between you and the vacuum of space is a shell of metal, fabric, pressure, and physics. The world's first space hotel isn't being built like a skyscraper. You don't pour concrete, stack floors, and install elevators. In orbit, every wall is a life support system, every joint is a pressure boundary, and every tiny mistake can become catastrophic. So to understand how a space hotel is actually being built, think of it like modeling with raw clay. First, you shape the core forms. Engineers start with pressurized cylinders, often made from advanced metals like titanium or aluminum alloys, because cylinders handle internal pressure far better than flat walls. A box wants to bulge and tear apart. A cylinder spreads force evenly, like a soda can holding carbonation. Around that pressure shell, you add layers, insulation, radiation shielding, and tough fabrics like Kevlar or similar high-strength materials designed to absorb impacts. And impacts matter. In orbit, even a paint fleck can hit like a bullet because objects travel at thousands of miles per hour. Micrometeoroids and orbital debris are one of the most lethal threats to any space hotel. That's why the outer shell isn't just armor, it's a layered defense system. The first layer breaks the particle apart. The layers behind it spread out the energy. The goal is simple: stop one tiny rock from turning a luxury suite into an emergency. But the biggest challenge is gravity. Humans don't do well in weightlessness forever, so many space hotel designs use centrifugal artificial gravity. That means part of the station rotates, creating an outward force that feels like gravity under your feet. But spin too fast and guests get dizzy. Make the ring too small and the difference between your head and your feet becomes uncomfortable. So engineers have to balance radius, rotation speed, mass, and stability. It's not science fiction, it's orbital physics. Then come the docking hubs, modular connection points where capsules, hotel rooms, labs, and power systems snap together. These hubs must stay airtight while handling motion, vibration, docking forces, and brutal temperature swings. In sunlight, surfaces can heat up dramatically. In shadow, they can freeze. That thermal expansion makes materials grow and shrink, so seals must flex without leaking. Building a space hotel is really about bridging the vacuum, turning fragile modules into a safe, pressurized habitat that can survive speed, debris, radiation, heat, cold, and human comfort. The dream is luxury in orbit. The reality is engineering against the void. Subscribe for more.